Hello guys, welcome to my class. Today we are going to learn how to design and analyze a T-beam. We can say T-beam or floor beam. Okay, so here is the section of the beam. This length is 3000 millimeter, this is 50 millimeter, this is 400 millimeter, and this is 300 millimeter. Okay, this is the flange and this is the wave. So now we are going to analyze and design the T-beam. So first open STAAD.Pro, go to new project, click on space, give a file name T-beam, length unit meter and force unit kilonewton, then click on next, click on add beam, then finish. Okay, so first we have to create a node first. Select here for create a node and switch off the snap mode. Now according to our design, we have to the beam rest on the columns. So at first we create two columns first, then the T-beam will rest on those two columns. Okay, now copy the node by node cursor, select Ctrl C from your keyboard, Ctrl V from your keyboard, paste for the node in the y direction is up 3 meter, the length is 3 meter, then enter from your keyboard. This is the shortcut of STAAD.Pro. Ctrl C for copy the node, Ctrl V for paste the node, enter. Okay, now again select the upper node, copy the node, paste the node, and in the x direction it will be 3 meter, the beam will be 3 meter, or you can say 4 meter, give 4 meter, then enter. Again copy the node, end node of the beam, Ctrl C from your keyboard, Ctrl V from your keyboard, in the y direction it is the minus y direction, in the lower, okay, 3 meter. Okay, now I have to add the nodes by add beam. So select add beam and just join the nodes. Okay, now we have our columns and beams. Okay, so now I have to fix the columns. For that, go to support page, click on create fixed, click on add, select the support, select the nodes and click on assign to selected nodes. For that, this is selected, then assign it. Yes, support has been given. Now go to the member property, go to define columns, go to rectangle. This is going to rectangle columns. Columns are 500 millimeter by 500 millimeter, in the converting meter is 0.5. Add. Now for the T-beam. Okay, now goes to the drawing and I'm going to minimize it for your better understanding. Okay, go to define, go to T-beam. Now see the picture. The upper is ZD, this is ZD, this distance is 3000 meter, you give 3 meter, it is on the millimeter, and the YD is the total distance, that is 400 millimeter and 50 millimeter, that is 450 millimeter. In the meter it will be 0.45. Now the YB, that is the wave. Okay, now YB value is 400 millimeter, in the meter is 0.4. ZB that is 300 millimeter. In the meter it will be 0.3. Okay, now check the values again. ZD is 3000 millimeter, LZ 3 meter, YD is 450, that is 0.45, YB is 400, that is 0.4, and ZB is 300 millimeter, that is 0.3. Then add it, close it. Now maximize it. Now we have our T-beam property. Now select the column property, select the columns. Okay, now click on assign to selected beams, assign yes. Now for the T-beam, select the member and select the property of the T-beam, click on assign to select beams, assign yes. Now go to the 3D render view for the view. Now you have your T-beam. Okay, or you can check the only beam by selecting that, and there is your T-beam. Okay, now I have to keep the load. Go to load case detail, click on add, click on dead load. Okay, give a title, date, add it, close it, click on add some loads, that is first of self weight and the member load. Give a member load, it is UDL minus 10 kilonewton, as you say. Add the node UDL self weight goes in a whole structure, so we go to the assign to view, assign yes, and the UDL goes to the beam. Okay, now click on assign to selected beams, that is assigned, that is selected, click on assign yes. Now you see all the loads are given. Now you have to analyze it. For that, go to commands, analyze, perform analyze, select all option, click on OK. Now go to analyze, run analyze, save. See, there is no error, no warning, no notes. You done a perfect job. Okay, go to the, you can go to the view output file or see the total applied load, what we applied, and total reaction load. It is a reaction. Okay, in the y direction. Okay, then go to the post processing or view the value, press control or see the values, see the deflection, see the bending here on Z, axial force. Okay, go to the beam, you get the bending on Z, bending on Y, torsion, okay, shear on Y. You can have the all values, or there is a table on the values. Okay, now I have to design it. For that, go to design, go to concrete, select your code. I'm going to select IS 456, then select the parameters, available parameters, and select parameters. We're going to select here. For that, you can select it and click that, or you can double click on the parameters, FYM and FC, then OK. Now define the parameters. Clear cover is 0.025 for 25 millimeter, then add it. FC for FCK 20,000, then add it. FYM 415,000, add it. Now these parameters goes to the whole structure. For that, go to assign to view, then assign, then yes. It is same also. If I mean goes to assign to view for So structure, now the parameters are assigned. Now go to commands, go to design beam, add, and design the column, add. Now for beam, goes to beam, select the beam, assign selected beams, assign yes, and for the columns, select the columns, pressing Ctrl from your keyboard and assign to selected beams and assign, then yes. Okay, all are complete. Now go to the analyze it, perform analyze, okay, analyze, sorry, analyze, perform analyze, no print, okay, analyze. It does not take comment, analyze, perform analyze. You can go to all, okay, now analyze, go to editor, delete the perform analyze it and delete from your keyboard. Now save it. Now we are going to find what is the problem. Go to comment, analyze, perform analyze, okay, analyze, run analyze, then save it. You see there is no error, no warning, and no notes. So we have done all the perfect things, then done. Now for see the reinforcement, double click on the beam and you see the concrete reinforcement. Top reinforcement is 10 mm, 4 number, bottom reinforcement is 10 bar 4 mm, sorry 10 bar 4 bar 10 mm there. And you can see the loading, shear bending, deflection. Okay, now in the tutorial the analyze is not taken. Okay, for that if you want done something wrong, then change it after analyzing it. Then if you analyze it double or thrice in one at a time, then it will show a error. For that go to, if you want to remove the error, go to the STAAD editor, just delete the perform analyze, or you down if you want to remove loads or property, you can delete the property or load. See there is a self weight, we give the self weight, we give the member load, all the things are here also. Okay, so you give also the concrete design for reinforcement for columns. Okay, go to the post processing, you can have the reaction for columns, select it for move the reaction. See the beam, the bending moment on the beams. Okay, so that's how you design and analyze a T-beam. Okay, so keep practicing it. Okay, so that's it, and thank you for watching my video, and keep subscribing on my channel for more excitement video. Bye.